morning. My name is Shino. I am the alternate to the New York co-chair of the Citizens Advisory Committee of New York, New Jersey Harbor and Estuary Program. I'm going to be your moderator for the first panel, which is titled, What Makes the Water Dirty, Why It Matters, and What We Can Do About It. So I would like to call Kate, Franco, and Susie up to the witness stands, please. And while they're settling down, I'm going to read a brief bio of the three speakers. Here is how we're going to handle the Q&A for all the panel sessions. We're going to be distributing little index cards. I'd like you to write down your questions while the presentation is going on. We are going to collect them, and depending on the time available for Q&A at the end of each panel session, we will be able to go through all of them, or we might just be able to cover a few of the questions that are pertinent. So we'll be distributing cards during the presentation. Our first speaker is Kate Zidar from the SWIM Coalition, that stands for Stormwater Infrastructure Matters Coalition. Kate is an environmental planner with a professional focus on watershed management, and she is the executive director of Newtown Creek Alliance. The rest of the bio is in your packet, so I'm not going to go on. I'd rather give the speakers more time. The second speaker is Dr. Franco Montalto from Drexel University. He is a professional engineer, licensed civil environmental engineer, and a hydrologist with 20 years of experience working in urban and urbanizing ecosystems. And the third speaker is Suzanne Stenzel-Husley from Brooklyn College. Susie is currently a doctoral candidate in the Earth and Environmental Science program at the CUNY Graduate Center. So, I'd like to have Kate come up.
So, hello, good morning. Should I press the buttons? I can just kind of do this. Right?
Why don't I do that?
Well, do you want Oh, I'm going to be pointing at stuff anyway, so it's fine. So I'm here to speak to you a little bit about the basics of water quality. Although I recognize so many faces here that I'm sure that you've all heard my spiel before, but so I'll try to maybe throw in some breaking news. I am here today to represent the SWIM Coalition, which is a citywide coalition that many of you are part of, and if you're not, then come on in. The water's need you. And we basically are focused on green infrastructure and cutting off negative stormwater impacts in the New York City area via green infrastructure, investment in stormwater management. And I'm going to talk to you a little bit about why that's important. My day-to-day work is in the Newtown Creek, which is the industrial water body between Brooklyn and Queens, which if I'm going to give anybody an intro to water quality basics, it's a great place to start because it's an extreme example of negative water quality impacts in New York City. So I'll try to go quickly. And whenever I talk about water quality, I really try to focus on three main things. Of course, there's sources of pollution, there's point sources, there's discharges happening of contaminants throughout the harbor estuary system. But in terms of overall water quality, these are the three things that my background is in urban planning and watershed management, so these are the three things that I focus on. The first thing is wet weather impacts, which we already started to speak about a little bit today. So wet weather impacts include both direct storm impacts, as well as this thing called CSO, combined sewer overflow, and I'll speak to that. In particular, with my water body on Newtown Creek and industrial waterfronts around the area in New York and New Jersey, historic contamination of sediments is something that I don't want to say it's a luxury, but with water quality really improving over the last several decades, this is something that we're turning our focus to now. So the Hudson itself has had a Superfund program active for the cleanup of PCBs for a while, but just down here in the city area, we have 3 active Superfund sites that are focusing on water bodies now, including Newtown Creek. And then I like to say that most problems that happen in the water start on land. And so pollution in the watershed, pollution on land, also historic kind of in a separate bucket. So what is a watershed? My watershed happens to be Newtown Creek. That's where I live, that's where I work. And the watersheds in an urban setting are not very good, a little complicated. They're not just you put a drop of water over here, it runs down via topography and lands in a creek or a reservoir or basin. We have something called sewer sheds that kind of add an extra added layer of activity, of action to the urban water system. So just to explain kind of what happens on my water body and what happens in most urban water bodies is we have a natural, quote unquote, watershed where that would happen if you are a raindrop, you go down to the creek. But then these two outlined areas, this blue area, basically almost where we are today, as well as the red area in Queens, these are sewer sheds. These are areas of sewering that are connected to specific sewage treatment plants. So during normal dry weather operation, on Newtown Creek, we have the Newtown Creek sewage treatment plant. So we have the natural water body and then this extended water body. We have the natural watershed and we have this extended sewer shed. And this is happening all over the city. I'm sorry, you can't get a map that shows New York and New Jersey, but this is the city's 14 sewage treatment plant sewer sheds. And so we can think of the city as an interlocking network of sewer sheds and watersheds. And when it rains, so that works very well during dry weather days, right? And then whenever it rains, the sewer shed has a finite capacity, and whenever it's exceeded, the sewer system basically needs to utilize its escape valves. Combined sewer overflow outfalls are located all along the waterfronts throughout the estuary, and in New York City, we have over 400 actual outfall sites. But they're not all created equal. Some of them drain larger areas than others. And this is a map. It might be a little difficult for you to see, but I can get it to you if you're interested in these kinds of documents. That shows the red dots as the top tier CSOs that are responsible for 50% of the overall overflow of combined sewer effluent annually. And all of these dots basically together make up 90%. So a relative handful are the trickier ones that really the city and advocates are targeting today. You notice there's about 5 of those dots on Newtown Creek. So this is the combined sewer overflow outfall. They're marked with signs. The signs have been slightly improved. However, notification of these events is something that's of particular concern for water body users. And we can talk about legislation that's happening to improve public notification, but also there are community scale programs that I'll mention briefly. This is what it looks like. They're not all as bad, but this is kind of the extreme example. This is why people are organizing around this issue. On the left-hand side, you can see direct stormwater impact. So many waterfront properties, in particular in the area that I work in, we have a direct stormwater sheet flow that happens into the creek. So these are both things that are of concern. There's kind of several strategies to go after for stormwater management. And this is how we get there. So we have a city that's increasingly impermeable, and then we have, where we do have open space, it's often not designed to really capture these multiple benefits of stormwater management as well as open space. So that's where we get to green infrastructure, which includes basically stewarding the land. So this is compost around a drip line. This is an activity that I actually did with young kids. But there's a more intensive design that the city and green roof professionals and stormwater managers are going after. This is a green roof and street side swales. There's all sorts of things happening in the city today. I mentioned that this is a collaboration between the Swim Coalition and Newtown Creek Alliance. I mentioned that public notification of sewer overflows is an important aspect. Until we solve the problem, we need to know about it. And so one of the programs that we're working on is called Weather in the Watershed, where we put weather stations on libraries throughout the watershed for Newtown Creek that help us anticipate knowing a few things about the sewer system capacity, we can anticipate within some margin of error that we actually don't know yet. It's a system that you calibrate by going out in the rain and looking at a sewer overflow. So it's a fluid system. That's supposed to be a hilarious joke, but for educators, it's a really For educators, it's really providing a wealth of information. So we have an open source mountain of data about Newtown Creek watershed and the weather systems that have passed through in the last year. So in particular, we're ramping this program up for hurricane season. This is our data from last year. You can see the barometric pressure on the day that Sandy came through. Just took a nosedive. So this is something that we can also, we can use to learn more about the watershed, just beyond the CSO. So historic contamination. This is a photograph from 1924, an aerial shot of Newtown Creek, and this is the Standard Oil and the Pratt Oil operation. So Pratt Oil on the north side of the creek, Standard Oil on the Brooklyn side. And there's a legacy for these industries that operated in many parts of New York City for decades, and the contamination ends up in the sediments. These operations occurred before we had a sewer system, before we had an EPA, before we had Clean Water Act, and so the sewer really was the water body. So the contaminants are residing there, and what our aspirations are for the Superfund designation in our area is that we'll be able to finally address the many feet, sometimes 15 to 20 feet of black mayonnaise of industrial waste that basically line the bottom of the industrial water body. And this is important in the ecosystem because toxic sediments in a water body is a way to reintroduce contamination via the food web. So this, the plants grow, water quality slightly improves, the food web comes into play, and all of a sudden you have bioaccumulation and reintroduction of these toxins in the food web. So it's important to address it. The historic contamination also lives on land. This is a map showing the areas of concern in terms of remediation efforts on land that are happening around Newtown Creek. And again, you could look at something like this for any industrial water body and many waterfronts. So we also seek to basically, the reason why I add this as kind of a separate thing is, let's say you are implementing a stormwater management project, hypothetically, in an industrial area, and you want to, your first goal is to improve water quality. And you design something to basically infiltrate stormwater into a vegetated area or a constructed wetland or any of the wonderful things that people are bringing to the city. You do that in an industrial zone where there's historic plumes of solvents, of oil, of heavy metals. And the water that you're infiltrating could potentially mobilize this contamination again. So the historic contamination is a tricky problem because it kind of interrupts some of our best thinking about the strategies that we use to fix other water quality problems. So this is a tricky thing for the city. And these are two of the